20 years ago, a fisherman off the coast of Taiwan hauled up something very strange and very rare from the bottom of the sea floor. It was what appeared to be a human jawbone, but rather than being from a grisly murder of a body disposed of at sea, it turned out to be one of our most enigmatic ancient cousins. It turned out to be the jawbone of a Denisovan. To understand just how rarefying this is, you need to know that every single thing we know about the Denisovans comes from 5 fossils from Denisova Cave in Siberia, 1 from Karst Cave in China, and 1 fossil from Tam Nu Hao Cave in Laos. We're talking about 4 molars, 1 finger bone, 1 long bone, and 1 jawbone in total. That's all we have of the Denisovans. So this guy was found about 20 years ago, and there's been some debate as to whether he belongs to a Homo erectus, a Homo sapiens, or a Denisovan. But using a relatively new technique called paleoproteomics, which looks at the proteins and amino acids, we're able to compare this sample to other known Denisovans, and this one most closely aligns with that of Denisovans. Here's where it gets a little tricky though. Because this dude was underwater for so long, it is completely waterlogged, meaning the carbon-14 dating and uranium basically doesn't work. We're also not able to get DNA out of this, so A, we can't date it, and B, we can't 100% say that this is a Denisovan. However, this jawbone was found with a bunch of animal bones, and they were able to date those. The problem is, A, I don't know how they dated them, they don't say, and B, there's 2 different dates. We've got 10,000 to 70,000 and 130 to 190,000 years ago, so it's quite a big date range. However, if it's the first, the 10,000 one, this would make this the youngest Denisovan fossil ever found. Now that we know more about the Denisovans and the Neanderthals as well, we're starting to uncover that the Neanderthals were covering most of Europe in the west, and that the Denisovans were covering most of Asia and Southeast Asia and even parts of Russia in the east, with a whole bunch of mixing in the middle. And we even have multiple lines of evidence for this, with DNA that shows that people who live up here have Neanderthal DNA, and the people that live over here, including people from Southeast Asia, Asia, even Aboriginal Australians and Native Americans, have Denisovan DNA, whereas most people over here don't. What this tells us is that as we moved out of Africa, we most likely mixed with the Neanderthals and then headed off to the east and mixed with these before going off to, Australia and America, while European populations stayed up here. And that's why they don't have any or very little Denisovan DNA, and everybody who crossed this kind of line here has a ton of Denisovan DNA. And besides the fact that it's super interesting, at least if you're a nerd like I am, this can lead to real-world consequences. For example, we now know that Neanderthal DNA is responsible for several diseases, including Crohn's disease, type 2 diabetes, and smoking addiction. Hey, if you made it this far, you must have liked the video, so don't forget to hit follow. More content coming soon. Also, do me a favor, go back and check out my video about the museum. It's not doing so well, and it would be cool if, it did a little better anyway. Okay, bye.